Discovery Program. The Discovery Program is a series of solar system exploration missions funded by the U.S. National Aeronautics and Space Administration (NASA) through its Planetary Missions Program Office. Each mission has a cost cap, at a lower level than a mission from NASA's New Frontiers or Flagship Programs. As a result, Discovery missions tend to be more focused on a specific scientific goal rather than serving a general purpose. The Discovery Program was founded in 1990 to implement then NASA Administrator Daniel S. Goldin's policy of faster, better, cheaper planetary science missions. Existing NASA programs had specified mission targets and objectives in advance, then sought bidders to construct and operate them. In contrast, Discovery missions are solicited through a call for proposals on any science topic. Selected missions are led by a scientist called the Principal Investigator (PI) and may include contributions from industry, universities, or government laboratories. The Discovery Program also includes missions of opportunity, which fund U.S. participation in spacecraft operated by other space agencies, e.g., by contributing a single scientific instrument. It can also be used to repurpose an existing NASA spacecraft for a new mission. As of 2017, the most recently selected Discovery missions are Lucy and Psyche, the 13th and 14th missions in the program. History. In 1989, NASA's Solar System Exploration Division began to define a new strategy for solar system exploration up to the year 2000. This included a small mission program group that investigated missions that would be low cost and allow focused scientific questions to be addressed in shorter time than existing programs. The result was a request for rapid studies of potential missions, and NASA committed funding in 1990. The new program was called Discovery. The panel assessed several concepts that could be implemented as low-cost programs, selecting Near Shoemaker as the first mission. Near became the first launch in the Discovery Program on February 17, 1996. The second mission, Mars Pathfinder, launched on December 4, 1996, carrying the Sojourner rover to Mars. Missions. Standalone missions. Missions of opportunity. These provide opportunities to participate in non-NASA missions by providing funding for a science instrument or hardware components of an instrument, or for an extended mission for a spacecraft that may differ from its original purpose. Espera 3, an instrument designed to study the interaction between the solar wind and the atmosphere of Mars, is flying on board the European Space Agency's Mars Express orbiter. Launched on 2 June 2003, it has been orbiting Mars since 30 December 2003. The principal investigator is David Winningham of Southwest Research Institute. NASA contribution to the joint ESA-CNES Lander Mars meteorological mission was planned, consisting of meteorological, seismic, and geodetic instruments. However, the mission was terminated prior to its 2007 launch. Moon Mineralogy Mapper M3 is a NASA-designed instrument placed on board the ISRO's Chandrayaan orbiter selected in February 2005. Launched in 2008, it was designed to explore the Moon's mineral composition at high resolution. M3's detection of water on the Moon was announced in late September 2009, 1 month after the mission ended. The principal investigator was Carl Pieters of Brown University. Extrasolar Planet Observation and Deep Impact Extended Investigation (EPOXI) was selected in July 2007. It was a series of 2 new missions for the existing Deep Impact probe following its success at Tempel 1. The Extrasolar Planet Observations and Characterization (EPOC) mission used the Deep Impact high-resolution camera in 2008 to better characterize known giant extrasolar planets orbiting other stars and to search for additional planets in the same system, as well as to investigate possible moons and ring systems of said exoplanets. A secondary science goal was to better observe the Earth in both infrared and visible light in order to create better computer models of exoplanets. The principal investigator was L. Drake Deeming of NASA's Goddard Space Flight Center. The Deep Impact extended investigation of Comet's Dixie mission used the Deep Impact spacecraft for a flyby mission to a second comet, Hartley 2. The goal was to take pictures of its nucleus to increase our understanding of the diversity of comets. The flyby of Hartley 2 was successful, with closest approach occurring on November 4, 2010. Michael Ahern of the University of Maryland was the principal investigator. New exploration of Tempel 1 and XT was selected in July 2007 together with the epoxy extension. It was a new mission for the Stardust spacecraft to fly by Comet Tempel 1 in 2011 and observe changes since the Deep Impact mission visited it in July 2005. Later in 2005, Tempel 1 made its closest approach to the Sun, possibly changing the surface of the comet. The flyby was completed successfully on February 15, 2011. Joseph Veverka of Cornell University is the principal investigator. Strophio is a mass spectrometer that is a part of the Serena instrument package on board the Mercury Planetary Orbiter component of the ESA BIPI Colombo mission. Strophio will study the atoms and molecules that compose Mercury's atmosphere to reveal the composition of the planet's surface. Stefano Livi of Southwest Research Institute is the principal investigator. Megan Mars Moon exploration with Gamma rays and neutrons is an instrument planned to fly aboard the Martian Moon's Exploration MMX, a Japanese aerospace exploration agency JAXA probe to Phobos and Deimos launching in 2024. Megan includes a gamma-ray spectrometer and a neutron spectrometer. David J. Lawrence of Johns Hopkins University is the principal investigator. In addition, the Lunar Reconnaissance Orbiter has been managed under the Discovery Program since the Lunar Precursor Robotic Program was terminated. Mission timeline, proposals and concepts. However often the funding comes in, there is a selection process with perhaps 24 concepts. These sometimes get further matured and reproposed in another selection or program. An example of this is Susuri mission, which was passed over in favor of the successful Stardust mission, but was eventually flown as Genesis, while a more extensive mission similar to InSide was flown as Juno in the New Frontiers program. Some of these concepts went on to become actual missions, or similar concepts were eventually realized in another mission class. This list is a mix of previous and current proposals. Additional examples of Discovery class mission proposals include Whipple, a space observatory to detect objects in the Oort cloud by transit method. Io Volcano Observer, currently proposed for either mission 15 or 16, a Jupiter orbiter designed to make 10 flybys of the volcanically active moon Io. Comet Hopper C. Hopper, a mission to Comet 46P/Wirtanen that would have utilized multiple short flights to repeatedly land on the comet's nucleus in order to map various geological processes such as outgassing. Titan Mare Explorer Time, a lander mission to explore one of the methane lakes found in the North Polar region of Titan, a moon of Saturn. Susuri, similar to the later Genesis mission. Hermes, a Mercury orbiter, similar to the Messenger Mercury orbiter. InSide Jupiter, an orbiter that would map Jupiter's magnetic and gravity fields in an effort to study the giant planet's interior structure. The concept was further matured and implemented as Juno in the New Frontiers program. The Dust Telescope. The Dust Telescope would combine a trajectory sensor and a mass spectrometer to allow the elemental and even isotopic composition to be analyzed. OSIRIS origins, spectral interpretation, resource identification and security, an asteroid observation and sample return mission concept selected in 2006 for further concept studies. It further matured and launched September 8, 2016 as OSIRIS-REx in the New Frontiers program. Small Body Grand Tour, an asteroid rendezvous mission. This 1993 concept reviews possible targets for what became near 4,660 Nereus and 2019 Van Albada. Other targets considered for an extended mission included Inca's Comet 2P 433 Eros, 1036 Ganymed 4 Vesta, and 4015 Wilson Harrington 1979 VA. Near Shoemaker visited 433 Eros, and Dawn visited 4 Vesta. Comet Coma Rendezvous Sample Return, a spacecraft designed to rendezvous with a comet, make extended observations within the cometary coma but not land on the comet, gently collect multiple coma samples, and return them to Earth for study. Similar to Stardust. Micro-Exo Explorer, a spacecraft that would have utilized a new form of microelectric propulsion called microelectrofluidic spray propulsion to travel to a near-Earth object and gather important data. Mars-focused. Pascal, a Mars Climate Network mission. MUD Mars Upper Atmosphere Dynamics, Energetics, and Evolution, an orbiter mission designed to study Mars' upper atmosphere. Similar to MAVEN of the Mars Scout program. P-Cross, similar to L-Cross, but directed towards Mars moon Phobos. Merlin, a mission that would place a lander on Mars moon Deimos. Mars Moon's Multiple Landings Mission M4 would conduct multiple landings on Phobos and Deimos. Hall, a Phobos and Deimos sample return mission. Aladdin, a Phobos and Deimos sample return mission. It was a finalist in the 1999 Discovery selection, with a planned launch in 2001 and return of the samples by 2006. Sample collection was intended to work by sending projectiles into the moons, then collecting the ejecta by means of a collector spacecraft flyby. Mars Geyser Hopper, a lander that would investigate the springtime carbon dioxide Martian geysers found in regions around the Martian South Pole. Magic Mars Geoscience Imaging at Centimeter Scale, an orbiter that would provide images of the Martian surface at 510 cm/pixel, permitting resolution of features as small as 2040 cm. Red Dragon, a Mars lander, and sample return. Lunar focused. Lunar sample returned from the South Pole Aitken Basin. Current geological models don't adequately describe the area, and this mission would have attempted to solve this issue. Examoon, in situ investigation on Earth's moon. Solho would use the moon as an occulter to look for exoplanets. Lunet, a lunar lander. Twin lunar lander, a double lander mission to better understand the moon's evolution and geology. Venus-focused. Venus multiprobe, proposed for a 1999 launch, would have dropped 16 atmospheric probes into Venus, which would fall slowly to the surface, taking pressure and temperature measurements. Vesper, a concept for a Venus orbiter focused on studying the planet's atmosphere. It was one of 3 concepts to receive funds for further study in the 2006 Discovery selection. Osiris and Grail were the other 2, and eventually Grail was chosen and went on to be launched. E-Star Venus Sample Targeting, Attainment and Return, a Venus sample return mission, with a goal of understanding Venus evolution. The mission would have consisted of a Venus orbiter with an attached lander. The lander would fall through the Venusian atmosphere, collecting samples along the way as well as after landing through the use of a mole. Said lander would launch those samples into a low orbit, where they would rendezvous with the orbiter, returning the samples to Earth. VEVA Venus exploration of volcanoes and atmosphere, an atmospheric probe for Venus. The main component is a 7-day balloon flight through the atmosphere accompanied by various small probes dropped deeper into the planet's thick gases. Venus Pathfinder, a long-duration Venus lander. Raven, a Venus orbiter radar mapping mission. Valor, a Venus mission to study its atmosphere with a balloon. Twin balloons would circumnavigate the planet over 8 Earth days. Venus aircraft, a robotic atmospheric flight on Venus atmosphere using a long-duration solar-powered aircraft system. It would carry 1.5 kg of scientific payload and would contend with violent wind, heat, and a corrosive atmosphere. Zephyr, a rover concept that would be propelled by the wind force on its vertical wing sail. Conceived in 2012, the project has since made progress in developing electronic components that would allow the vehicle to operate for 50 days on the surface of Venus without a cooling system. Selection process. Discovery 1 and 2. The first 2 Discovery missions were Near-Earth Asteroid Rendezvous Near, later called Shoemaker Near, and Mars Pathfinder. These initial missions did not follow the same selection process that started once the program was underway. Mars Pathfinder was salvaged from the idea for a technology and EDL demonstrator from the Mars Environmental Survey program. One of the goals of Pathfinder was to support the Mars Surveyor program. Later missions would be selected by a more sequential process involving announcements of opportunity. In the case of Near, a working group for the program recommended that the first mission should be to a near-Earth asteroid. A series of proposals limited to missions to a near-Earth asteroid missions was reviewed in 1991. What would be the Near spacecraft mission was formally selected in December 1993, after which began a 2-year development period prior to launch. Near was launched on February 15, 1996, and arrived to orbit asteroid Eros on February 14, 2000. Mars Pathfinder launched on December 4, 1996, and landed on Mars on July 4, 1997, bringing along with it the first NASA Mars rover, Sojourner. Discovery 3 and 4. In August 1994, NASA made an announcement of opportunity for the next proposed Discovery missions. There were 28 proposals submitted to NASA in October 1994. In February 1995, Lunar Prospector, a lunar orbiter mission, was selected for launch. 3 other missions were left to undergo a further selection later in 1995 for the 4th Discovery mission, Stardust, Yuri, and Venus Multiprobe. Stardust, a comet sample return mission, was selected in November 1995 over the 2 other finalists. Discovery 5 and 6. In October 1997, NASA selected Genesis and Contour as the next Discovery missions out of 34 proposals that were submitted in December 1996. The 5 finalists were Aladdin Mars Moon Sample Return, Comet Nucleus Tour Contour, Genesis Solar Wind Sample Return, Mercury Surface, Space Environment, Geochemistry, and Ranging Mission Messenger, Venus Environmental Satellite VESAT. Discovery 7 and 8. In July 1999, NASA selected Messenger and Deep Impact as the next Discovery Program missions. Messenger was the first Mercury orbiter and mission to that planet since Mariner 10. Both missions targeted a launch in late 2004, and the cost was constrained at about US $300 million each. In 1998, 5 finalists had been selected to receive US $375,000 to further mature their design concept. The 5 proposals were selected out of about 30 with the goal of achieving the best science. Those missions were Aladdin, Deep Impact, Messenger, Inside Jupiter. Vesper, Aladdin, and Messenger were also finalists in the 1997 selection. Discovery 9 and 10. 26 proposals were submitted to the 2000 Discovery solicitation, with budget initially targeted at US $300 million. 3 candidates were shortlisted in January 2001 for a phase A design study: Dawn, Kepler Space Telescope, and Inside Jupiter. Inside Jupiter was similar to a later New Frontiers mission called Juno. Dawn was a mission to asteroids Vesta and Ceres, and Kepler was a space telescope mission aimed to discover extrasolar planets. The 3 finalists received US $450,000 to further mature the mission concept. In December 2001, Kepler and Dawn were selected for flight. At this time, only 80 exoplanets had been detected, and the main mission of Kepler to look for more exoplanets, especially Earth-sized. Both Kepler and Dawn were initially projected for launch in 2006. Discovery 11. The original announcement of opportunity for a Discovery mission released on April 16, 2004. The only candidate for selection for a concept phase A study was JASSI, which was a Jupiter flyby mission based on the New Frontiers mission Juno that was already under consideration for final selection. Eventually, Juno was selected as the second New Frontiers mission in 2005 and launched in 2011. No other Discovery mission proposed in response to the announcement of opportunity was considered for concept study, and therefore no Discovery mission was selected for this opportunity, although a mission of opportunity was selected, Moon Mineralogy Mapper, as part of the AO in 2004. The next announcement of opportunity for a Discovery mission was released on January 3, 2006. There were 3 finalists for this Discovery selection, including Grail, the eventual winner, Osiris, and Vesper. Osiris was very similar to the later OSIRIS-REx mission, an asteroid sample return mission to 101,955 Bennu, and Vesper, a Venus orbiter mission. A previous proposal of Vesper had also been a finalist in the 1998 round of selection. The 3 finalists were announced in October 2006 and awarded US $2 million to further develop their proposals for the final round. In November 2007, NASA selected the Grail mission as the next Discovery mission, with a goal of mapping lunar gravity and a 2011 launch. There were 23 other proposals that were also under consideration. The mission had a budget of US $375 million then-year dollars, which included construction and launch. Discovery 12. The announcement of opportunity for a Discovery mission released on June 7, 2010. For this cycle, 28 proposals were received. Out of the 28 proposals, 3 finalists received US $3 million in May 2011 to develop a detailed concept study. InSight, a Mars lander. Titan Mare Explorer Time, a lake lander for Saturn's moon Titan with methane-ethane lakes. Comet Hopper C. Hopper to study cometary evolution by landing on a comet multiple times and observing its changes as it interacts with the Sun. In August 2012, InSight was selected for development and launch. The mission launched on May 5, 2018, and successfully landed on Mars on November 26, 2018. Discovery 13 and 14. In February 2014, NASA released a Discovery Program draft announcement of opportunity for launch readiness date of December 31, 2021. The final AO was released on November 5, 2014, and on September 30, 2015, NASA selected 5 mission concepts as finalists. Each received $3 million for 1 year of further study and concept refinement. Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging Davinci. Venus Emissivity, Radio Science in SAR Topography and Spectroscopy Veritas. Near-Earth Object Camera NEO-CAM. Lucy. Psyche on January 4, 2017. Lucy and Psyche were selected for the 13th and 14th Discovery missions, respectively. Lucy will fly by 5 Jupiter Trojans, asteroids which share Jupiter's orbit around the Sun, orbiting either ahead of or behind the planet. Psyche will explore the origin of planetary cores by orbiting and studying the metallic asteroid 16 Psyche. Discovery 15 and 16. On December 22, 2018, NASA released a draft of its Discovery 2019 announcement of opportunity, which outlined its intent to select up to 2 missions with launch readiness dates of July 1, 2025, December 31, 2026, and/or July 1, 2028 DEC 31, 2029 as Discovery 15 and 16, respectively. The final announcement of opportunity was released on April 1, 2019, and proposal submissions were accepted between then and July 1, 2019. Finalists were announced on February 13, 2020. The final selections will be made in 2021. Finalists are Davinci plus Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging plus a Venus Atmospheric Probe. Io Volcano Observer, an orbiter to Jupiter to perform at least 9 flybys of Jupiter's volcanically active moon Io. Trident, a probe that would conduct a flyby of Neptune and its moon Triton. Veritas Venus Emissivity, Radio Science in SAR, Topography and Spectroscopy, a Venus orbiter to map the surface of Venus in high resolution. Other proposal submissions for Discovery 15 and 16 missions included asteroids, comets, centaurs, interplanetary dust Centaurus, a reconnaissance mission to explore multiple centaurs via flybys as a way to learn about solar system and planet formation. Chimera, a mission concept to orbit the highly active Centaur 29P/Schwarzmann-Wachmann 1 to study the evolutionary middle ground between the trans-Neptunian objects TNO and Jupiter family comets. Fossil fragments from the origins of the solar system and our interstellar locale, a spacecraft to be placed in an Earth trailing orbit to determine the composition of the local and interplanetary dust cloud. Mantis Main Belt Asteroid and NEO Tour with Imaging and Spectroscopy, a mission that would fly by 14 asteroids covering a wide range of types and masses. Venus. Yes. Hover Hyperspectral Observer for Venus Reconnaissance, a Venus orbiter that would perform spectral studies from the top of the atmosphere to the surface. Its main goal is understanding the mechanics of the Venus climate and atmospheric superrotation. Lunar Moon Diver, a lunar lander which would deploy a rover to rappel down a deep pit, analyzing the exposed geological layers and investigate if the pit connects to a lava tube. Lunar Compass Rover, a rover designed to explore a near-side magnetic region and swirl, and would answer some questions in planetary science, including planetary magnetism, space plasma physics, space weathering, planetary geology, and the lunar water cycle. A proposal for Lunar Compass was not submitted to this discovery round. Isochron Inner Solar System Chronology, a mission that would perform a robotic lunar sample return of the youngest mare basalts. Nanoswarm, A lunar orbiter to investigate lunar swirls, space weathering, lunar water, lunar magnetism, and small-scale magnetospheres. Mars Compass Climate Orbiter for Mars Polar Atmospheric and Subsurface Science is a mission concept for a Mars orbiter to research the Martian climate record through the study of its ice deposits and their interaction with current climate. This mission is led by the Lunar and Planetary Laboratory at the University of Arizona and the Laboratory for Atmospheric and Space Physics at the University of Colorado, Boulder. Icebreaker Life, a mission concept led by the Ames Research Center for a lander to search for direct signs of life on Mars via biomarker detection, with a focus on sampling ice-cemented ground for its potential to preserve and protect biomolecules or biosignatures. Jupiter Magic Magnetics, Altimetry, Gravity and Imaging of Callisto is an orbiter reconnaissance concept to Jupiter's moon Callisto. Gallery. Artist's Impressions. Mission Insignias. This section includes an image of the Discovery mission's patches or logos, as well as the launch year. Launches. This section includes an image of the Discovery mission's rockets, as well as the launch year.